So, hi everyone, I hope everyone is doing well. So we will be starting in few minutes. People are still joining. Okay. Uh, just let me know once like my voice is properly like it's properly loud enough. Okay. Okay. So before starting, let me give you like a small introduction of myself. So I'm a working professional. I work as a full stack developer. Okay, and I just recently like completed my DSA preparation, and I just wanted to have a kind of a revision. So I thought maybe people who are like might be starting off or they might be in the between. So let me take few sessions and then like it will help me also to have a complete revision, and it will also help others to like grasp or learn something new. So okay, and let me share my screen. So one more thing, and in case like you have a doubt or something, you can either ping in the chat uh, or like wait for like to let me complete some like whatever topic I'm like we are going through or whatever question. Let me finish that, then we can discuss over that. So like it will not break my flow. Okay, so let me share my screen. Okay, let me know once if everything is properly visible. So I hope this is like properly visible, right? And the font size and everything is okay. Okay, perfect. I think this setting is perfect. Okay, so let's have a kick-off session today, and we'll have a like quick kick-off from arrays. We'll be taking up the arrays properties. So let's start from arrays today. Okay, so we quickly go through like the first thing comes into our mind, or like first thing what we should know about arrays. I think most of us are like having a programming background. So let us quickly discuss about the properties of arrays. Okay, can you guys like quickly tell me some of the properties of the array that one should know of the array data structure? Right, good. So first one we can say it is a homogeneous elements, right? Like you can only have integer, string, or anything, but it should be an homogeneous. The data type of that should be homogeneous. Other one, it is the linear in the data structure. Elements can be indexed contiguously, right? So Harini said it is a linear data structure. That means it is, we can say, contiguous in memory, right? Then it is index based. So we can say like it is a data structure which is having indexing. Then yeah, continuous. So it is a contiguous in memory. It is a contiguous data storage. Then so it have a zero-based indexing, right? Now, one few of the like very important properties we are missing out here are, if anyone more like when one wants to add, there are few very important properties we are missing out here, which is like very crucial in deciding whether to use arrays as a data structure or not in any form. Pardon? Yes, Manoj? Yeah, this we have already mentioned. Index starts from zero. So first thing, I think fixed length, right? Or fixed size. Yes, correct. It's not dynamic. Dynamic. It is having a fixed size. I think this is a very important property to consider. So if there is any problem or if there is any statement where we know that the size is going to be dynamic, so we like instantly know that arrays is something that we cannot use it, right? Then one more property. So fifth one, I think, is that we can have a random access, right? If there is an array of something 0 index to n, right, you can directly access that, like array like a of the first index value or array of a of like value of index at 2, like that we can directly access it and we can randomly access um, any of the position or any of the index. So this is also very important. Suppose like if I consider a data structure like queue or stack, so or any other data structure like that. So in that data structures or we cannot directly access it, right? If you say in linked list, we need to like go from the starting and then traverse it. We cannot access any random. So these are like very these two are like very deciding factor for this data structure to be selected at any problem or not. Okay, so after summing this up, we will quickly go through. So I'm hoping like from the most of us I already know the theories of the array, how to like create an array in different programming language. Like so if someone is using Java or C++, JavaScript, I think you must be already aware of how to create an array. So I'm just skipping that part and I'll be directly starting with questions which involves the operations on the array. Is that okay? Like, I think that will be like very basic part to cover. Okay, so like it is good to start off from a question directly, so it will like help us. Okay, so the question states as it's a very simple question of reverse string. So it says write a function that reverses a string. The input string is given as an array of string s, like the characters s. You must do this by modifying the input array in place with O of 1 extra memory. Okay, so we have this simple array of hello. So we have an array of like H, E, L, L, O. We need to reverse this string. So anyone wants to uh, explain this? It's a very simple one. If just anyone wants to explain what we can do here. Like, what is the first thing that comes to your mind when we want to reverse a string or like reverse the array? How can we do that? I think so. Okay, so I'll just take it. Mhm. Right. So we can traverse from the reverse direction, right? So suppose we have the length of n, right? Here the length is how much? 1, 2, 3, 4, 5. The length is 5. what we can do, we can write a for loop, right? Which will go from n to 0, or since it is a 0 based index, I will say from n minus 1 to 0. Then what we need to do, what we can do is like we can create another array, suppose A, right, of the same size, 5. And then what we can do is, suppose if we say this array is A and this new array we are creating is B. So B at position, you can say like n minus 1, let's just call this as I. Okay, this is what we are traversing as A of, let's call this n minus I, and this is I. So what I'm doing is I'm filling this B array with the values of A, but A I'll be traversing from the end, right? This is a very simple algorithm, right? Now the thing is, here it is written in place. That means of one extra memory. So we cannot create a new array here. Then, mhm, right. So whenever there is something in place is written, right? Whenever there is something in place is written, the first thing the like it should come into our mind is swap the values. Because since we cannot create an array, we already have what array available with us. So this as array we already have it. So what we need to do is like there is nothing other operation we can do. Only thing what we can do is swap the values in place. Now in this case, like what do you feel? What will be the best algorithm there to swap the values in like in its own place? Right, two pointers method, but like swap how? What value should be swapped? Like, should I swap H with E, or how is it? First and the last, like it's very intuitive. First, just select the first one, select the last one, start swapping it, right? O E L L H, right? Then O L L E H. We have swiped this, then we have swiped this, right? Then we will be swapping. So I think we are in the middle, right? If n is equal to 5, we are in the middle. So we are swapping this with this, we are swapping this with this. Now for this, we don't have any pair because we are in the between. It's not needed. So if it's just sum up in a pseudocode, how we can write the algorithm. It's very simple. I can start with the for loop from. So instead of a for loop, what we'll do is we create two pointers. Pointer P1 start from 0, pointer P2 which should start from n minus 1. Then what we can say, a simple while loop that um, P1 should always be less than P2. Okay, then we can create a temp variable, store the value of that array of suppose P1 here. Then P1 value we will change it to array of P2, and then simply array of P2 equals to 10. Okay, this is the swapping algorithm with the two pointers. So this is a like a pretty easy one, but we need to remember this algorithm. This is the very very useful algorithm which will be used in many questions, and like, this is something should be like by heart. If you see anywhere like some swapping is happening, you should not think twice, or like it should be like writing down your own name. This algorithm, swapping numbers, like or swapping values in the array to reverse down. So because you'll see when we do questions, there are questions like in which where the swapping algorithm is used very extensively. You need to swap the values, or you need to swap any instead of like this is a complete reversing algorithm, but instead sometimes you might need to just swap two values, or like swap and like in let's say suppose this is an array is there, and you just need to swap some particular from starting from index 5 to something like this, some sub array of it. So there are like multiple questions will be there where you'll see this algorithm. Okay, so I think this is fine, right? This is understood, right? Okay, so we'll move forward quickly. This one was like a pretty easy question. Okay, the next thing comes up here is a monotonic array. So an array is monotonic if it is either monotone in increasing or it is monotone in decreasing. Now the array nums is given, which is increasing if an I index is less than index j, and the number which is present at the I index should be less than or equal to the number present at the j index, and vice versa for the increasing one. So based on that, if it is I, like it should be either increasing or it can be either decreasing, right? But it can so either if it is increasing or decreasing, then we need to return true, and otherwise we need to return false. See, the question is pretty clear, right? So if I take an example, can anyone ping an example of like increasing? It's very simple, right? Increasing is like can be just 1, 2, 3, 6, 10, anything. It can be increasing, and it can be like decreasing 11, 10, 5, 4, 1. Right. This is increasing. So either it can be in this format or it can be in this format. So this question also seems very easy, but there is one algorithm I feel like which uh, interviewers look for, and which is like actually used in questions where you use monotonic array. So if anyone wants to suggest what we need to do here, how we can check this. Mhm. Right. Suppose if I just do this, right, as Pratik has said, and like this is what comes into our mind, right? The first thing that we can just compare each value, right? So instead of starting from 0, what I can do is start from 1. I'll go to n minus 1, right? And I'll just initiate a Boolean value with, let me do it with true, right? Initially, I will assume that it is true, and then whenever I find a violation, I'll make it false. So this is what like comes to in our mind, right? So now, but the question arises, if I'm comparing this, right? Um, I'll just try it, right? Nums of, I'm assuming that this is the I integer, okay? Then I minus 1, if it is less than or equal to nums I, right? First, one condition should be this. Another condition what we need to check is the previous element, like this will be for the increasing one. If it is less than, then it is increasing. If it is previous one is greater than the next one, then this is decreasing, right? But then again the question arises, what we should do of this answer. Suppose this is the answer variable. Now what should I do after this? Hmm. Right, so this seems correct. What I can do is, this is an integer. So what Pratik says is, we can do increasing plus plus, and if this is true, I'm going to do decreasing plus plus, right? And at the end, I want to, like, I'll be having an size n. Now I can check uh, if, like, increasing is equals to n or decreasing is equals to n, then I can say it's true. Else I'll say it's false, right? Like, is this correct? Will this work? Okay, so see, this will work, but what we are doing here is we are storing, like, creating. I think this is like not necessary, right? Instead of like storing the values, what we can simply do is make this as a boolean, this also as a boolean. So what we are doing actually is, this is like the direction we are storing, right? So increasing direction or decreasing direction. Initially, what I can assume is, like, both the directions are true. Increasing is also true, decreasing is also true. Then what I can simply do is, instead of like incrementing it, if it is not, I can simply add, if this is not increasing, I can make this as false. And if it is not decreasing, I can make this as false. So at the end, either of it will be true. Then if it is, like, either of it is true, then it's true. If both are false, that means neither it is increasing nor it is decreasing. And then it will return false. So both of these algorithms are fine. The first one, we will be storing some values, right? We can save some of, like, some memory and some operation instead of increasing it every time. So like we can have like we can save on that. One more thing what we can do is instead of checking it outside the for loop, we can also check it inside the for loop. So what this will do is at any point of time, it becomes like if it is increasing, right? If it is increasing, either this will be true. If it is decreasing, every time either the second condition will be true. At any point of time, suppose it stops becoming increasing, right? It becomes after 6, it becomes 4. This will become false, and we already know like it is not like till here it is not increasing, it's decreasing. This value will have already become like false, right? So as soon as like it reaches here, as soon as it reaches here, you'll come out of this loop and like it will directly return the value. So what we are doing is we are storing the directions. This as like this algorithm is somewhat actually I felt interviews look for. So I actually once did this question, but how I did is uh, instead of giving it in one for loop, I have given in two for loops. So what I actually did is like uh, initially only I checked inside the array for the first value and the last value. So if like these are um, if like 10 is greater than, then I'll say that okay, it might be increasing, or if it is like 10 and 1. So initially I'll say, okay, okay, this then I'll check for decreasing. If it was like this was like this, then I ran the for loop with this only first one condition, and then if it is like the second condition, then I ran for the for loop with the second condition only. So, but interview was like not very happy with this because it is like not actually the exact monotonic array that sorry, the not exactly the monotonic algorithm that we follow. So, as per the algorithm, we should be always be aware and like whenever we are looping through the array, it should be like one loop or the it should be a one pass of the array, and in that one pass every time like we are iterating through it, it should be we should be aware of the direction. So here we are already always aware of the direction, if it is true or if it is false, and at the end of each iteration we can check like what it is going to be, like if it is true or not. So yeah, I hope this one is clear, right? You can give reactions or gives a thumbs up if this one is clear. This one is also pretty simple, but for someone who have not seen this question before, uh, you can like remember this one. This is something, this algorithm is something that people or interview they look for. Okay, now let's go to the next one. Okay, so this one is like a very pretty interesting question. The text is the text size is visible to you, everyone. I feel it might be little too small for some people. Okay, so we'll quickly go through this question. So a permutation of an array of integers is an arrangement of its members into sequence or a linear order that we already know. Suppose we have 1, 2, and 3, then 2, 3, and 1, or 2, 1, and 3. So it is an arrangement of all the members, and it can be in any order. So 2, 3, 1 is a permutation of 1, 2, 3, and this was also a permutation of this. So this is what the permutation is. So an example is given 1, 2, 3, and then okay. Then the question says the next permutation of an array of integer is the next lexicographically greater permutation of its integer. What does it mean by lexicographically greater permutation? Or you can simply say the next greater uh, integer as a whole. And with like when we say lexicographically, it actually means like how things are arranged in a dictionary. So if I say, like, if I take an example of this 213 and 321, right? So which is like which will count lexicographically. So when we compare two things like in a dictionary, so we'll compare the like the first one, 2 and 3. Two is the smaller one, so this will come first. In case suppose here also we had three, right? Like these two. So first we'll complete compare the 3 and 3. Both are same. Then if they are same, we will check for the next value, 1 and 2. If we check for the next value, we'll see, right? 1 and 2. One is the smaller one, so you'll know the answer. Like this is the so this one is like the next lexicographically greater than this one. Okay. So then, for example, and all example is given. So I've actually taken out one example, which is like it will be like more easier to understand. Because the example they have given is actually a pretty simple one, 1, 2, 3, and like that. Okay, so here is the question. Given an array of integer nums, find the next permutation of nums. And that next permutation should be lexicographically greater. And one more thing, in place. So as you've already seen, in place means we cannot create a new array. We need to use swapping. Okay. Anyone wants to suggest, or if something is coming to your mind, how we can solve this? Okay, mhm. Let's follow that algorithm. Like if it is greater, this one is greater, no swapping. Then so you mean to say this should be now compared with the zero, or this should be compared with this zero? Now this one. Okay, so you mean to say this one will be here only because we are comparing this. Then 3, 5 will be compared with this, then 4. But it is the same value, right? And I'll give like some 2 minutes. Okay. Um, I'll suggest like just give it 2 minutes and take this example, right? And for example, I'll like give you one example what it actually wants. So suppose like 3, 1, 2, right? Or what I'll do, uh, suppose I have 1, 2, 3. Okay, let's list down all the permutations of it. What all permutations we can have is suppose 1, 3, 2, then 3, 1, 2, then 2, 1, 3, then 2, 3, 1. So 3, 2, 1. How many there? 1, 2, 3, 4, 5, 6. All are there because 3 factorial means 6. So this is formula for calculating the factorials. This is all right. Now suppose if I am given with value as 3, 1, 2. What is going to be the next permutation? Next, so you need to like arrange these in a lexicographical order, right? So I see next greater one will be 3, So the first value should be either 3 or greater than 3. 3 is the largest, so it should be 3 only. For 1, it should be the next greater than, so I think this one. So the next permutation will be 3, 2, 1. So if I do any swapping here, I don't think so. Like it's that algorithm is working here because if you see 3 is there, 1 has gone here, 2 has gone here, right? And if I take any another right number, 1, 3, 2, what will be the next permutation for this? So from like is there a number starting from 1? Yes, this one, but the second one is less than, so we cannot take this one. We have to take 1, 3, 2. Yeah, and for so we need to take from 2. Either we can take this one or this one, and we will take the smaller than like the values which are smaller. So I think this one is the smaller because here 3 is there, here 1 is there. So the next permutation will be 2, 1, 3. So does anyone like see any pattern here? If you see these two are swapped, but in this 1, 3, 2, 2 and 1, like I don't see anything is swapping. Even if we swap 2 and 1, then 3 is also swapped, and like I don't see any swapping pattern. Do you agree? Like there is no any like constant or any like any persistent or like any kind of a swapping pattern I'm observing here. At least so I like request you guys to like at least you can give a thumbs up so like I know that whatever I'm like explaining it's reaching to you. So, right. So there is nothing constant, right? Like so we need to find a pattern until and unless we don't find any pattern because algorithms and data structures like it is everything is based on pattern. If we find a pattern, likewise we found in the reverse string that we can just swap the first value with the last value, increase that pointer to 1, increase this pointer to 1, decrease that pointer to 1. If we just keep on doing this, it will be reversed, right? This is what we found out, right? So we need to find some pattern. If we know that pattern, we just need to code that. I'll give you an intuition, right? Now to know that intuition, what I'll do is, don't not remove this. Let's list this down in that like increasing order. I'll do 1, 2, 3. Then what should be the next one? Then 1, 3, 2 only. Then what should be the next one? It start from 2, then 1, then 3, then it can be 2, 3, 1, then can be 3, 1, 2, then 3, 2, 1. Okay. Now if I say what is the next greater permutation of this? So if you see, this is the smallest permutation, this is the largest permutation. One thing I've observed that if it is written in increasing order, it is the smallest one. If it is written in the descending order, this is the greatest one. So which feels like very obvious, like very intuitive, that if you want to have a greatest integer like form, so if we consider this instead of an array, which if we just consider it as an integer as a whole, like 321, right? So you can compare it and directly you can say if like you can just arrange all the integers like suppose I have given this value, right, for example. So if I just arrange this in descending order, 5, 4, 3, 2, 1, 0, this is going to be the largest number, largest permutation possible of this number. And the smallest permutation can be 1, 2, 3, 4, 5, 0, right? and all the permutations are going to be in between this. So suppose I'm just assuming in the question I have given this permutation, right? In case like if I've been given this permutation and the question says, give me the next permutation, what should I do? If it says, give me the next permutation, then it will definitely go to this circle, right? Because it doesn't make sense, right? They want me to give them like it should be the lexicographically greatest, or it can be like in lexicographically next permutation. I cannot have anyone like anything greater than that. So I should like return something which is like next to this. So it will like it will go in a circle. So what I'll be returning is I'll just return the reverse of this, reverse of the nums array. One intuition I have formed in my head that if a number is in decreasing order, like it is a monotonic array. So you can see all the dots are connecting. It is a monotonic array. We know it. Then uh, we found it like we know that it is uh, we need to do it in place. So we need to do swapping. We cannot create a new array. And this intuition that if it is the in monotonic decreasing, the next permutation will be the reverse of the numbers. Okay, one more thing, like one little thing I'll do, which will like I'll give you a hint on how to solve this question. Just I'll swap suppose one number out of this, right? In this set. What I'll do, I'll write it as 1, 4, 3, 2, 5, double 0. Or instead of that, I'll do one thing. I'll just as of now I'll just remove this one. Okay, or let me just take this one, this much value. So like I have initially 2154300. What I'll do is I'm taking only 4300. Is it possible to like directly tell this like what will be the next lexicograph that what will be the next permutation for this? I think it's very easy, right? Why? Because this is monotonic array. This is decreasing. What it will be 0, 0, 3, 4, right? Now if I just include 5 also, it will be 4 this. What will be the next value? 0, 0, 3, 4, 5. If I include one more thing, 1, then what it will be? I think now you might be like forming that intuition how to solve this question. Now just if somehow we figure out how to find the next permutation of this value, then this question is done, right? And what we need to do is actually if we figure out like suppose just try to figure this, what will be the next permutation? I'll directly write it, try to find a pattern. Is anyone trying to attempt this? Like, what will be the next permutation for this? Or I should write. You're missing one more digit, right? One is also there. So just write 300145. Correct? This will be the next permutation. So if you see the pattern, what actually I have done is I'll simply try to find out which one is the smallest in this. The smallest one is 3. right? Because what I do when I'm comparing two, like two integer, like these two arrays lexicographically, like when what I was doing, like when I've written 132 and I was trying to figure out the next permutation. What I checked is, out of all the permutations, is there like I'll try to check what are the choices that I have. So I'll check the first thing, one should always be there, three should always be there. The right, so I checked like okay, one is already there. What then I'll check three. So what all options do we have? So this is already done. Out of these we are checking. So for three, the next one, so it is already the greatest one. So I don't have any other option. So what I do it is like I've increased this. So what is the value that I should increase? So it should be the just the value which comes after this, right? Can I say that value will actually exist in the array, like the remaining array in this, right? That value will actually exist in the remaining array. For one, like I'm checking for something which is just greater than this, just greater than this value for one. What is that value? That value is something which will be in this array. And how to find out? I can say that value should be the minimum of this sub array. In this sub array, the minimum value is 2. So I'll write 2. Then what I can do is like 2 I've written there. So the only option I have, like I can swipe it, right? I just swiped it. But again, the issue is this is the like this is not the correct value. The next value is this. So what I observed is what I actually need to do is reverse this. Because see, I'm just finding out the next permutation, right? So till here, this is okay, right? So if you see till here, it is in the decreasing order, like it is decreasing order. So for the decreasing order value, if I want to like if I want to find the next permutation, I can just reverse this. So I just what I did, I just reversed it. So I just try to sum up everything, okay? Just let me know if like someone still have some doubt. So I'll go from the end and I'll check till where it is decreasing monotonic array. Or since I find like I'm going from the end, I can just check if it is increasing. Why I'm checking this? Because it is very easy to get the next permutation until and unless like it is an increasing, right? So I'll check. Okay, this is good. This is good. This is increasing. This is increasing. But here it is not increasing. So I'll call this as a breakpoint. So now I know that the breakpoint is what? N is equals to 1. Now, one intuition I have like, and I have one subarray which is from 1 to n, right? 1 to n, which is what? Which is decreasing. Now, to get the next permutation of this, only thing what I need to do is reverse this, correct? But at the breakpoint, what I need to do is I need to find the next number to this. Intuition I have already found is since I'm like looking for the next permutation, this one should have been like already taken care of, right? In the above options. For this, I'm looking for the next integer, right? It should be either equal to this or it should be greater than this, right? And anything it is like if it is greater than, it will be present in this one, in this array, right? And it will be what? It is going to be the minimum of what, right? What will be the minimum value? So minimum value which is just greater than this. So if I see what is that value, 0 is the minimum value, but it is less than 0, less than 1. 3 is the minimum value, next minimum value, it is just greater than 1. So it is fine. So what we'll do is we'll just swap it. 2, 3, 4, 5, 4, 1, double 0. So what we did here is we took the minimum value of out of this array, swapped it. So what this would actually do is it will also preserve this, right? Preserve the what to say, the decreasing order. Why? It is very intuitive, right? Since we are like looking for the minimum value from here, right? And that minimum value should be just greater than this. It will preserve the decreasing order. Now, the next thing what we just need to do is reverse this order. 2, 3, 0, 0, 1, 4, 5. And that's the correct answer. That is the next permutation. So we figured out one pattern, right? We have formed some, we have figured out some algorithms. We have figured out some patterns. The first pattern that is, if it is in the complete decreasing monotonic array, we just need to reverse that array. And if you just reverse that array, it will be the next permutation, right? And if you just want to get the next permutation, you just need to find out the next minimum value out of this and then swap it and then reverse the remaining array. So I'll just write the pseudocode for this. So what we can do is we'll just have a variable as a breakpoint. This will be a variable. Then we'll have a for loop from n minus 1 to 0, right? And what we'll do is we will always compare the previous value, right? Now since we are going from back in this direction, so the previous value will be actually I, and the next value will be minus of I minus 1. The next value, this will become the previous value, this will become the next value, previous value. Now the previous value should be greater than, and if it is less than the next value, or I will move the equal to sign actually. If it is strictly less than the next value, I'll say that break is which one? The next one, right? Break is I minus 1, and then I'll break the loop. Since I'm starting off from this value, right? Like, and I minus 1, I'm checking for the next one. So what I can do is I can go up to value 1. So, like avoiding the out of point expound exception. So this is fine, right? To find out the breakpoint. Now, once we have the breakpoint, what we need to do is till the breakpoint, we already know it will be the swapping, right? So we already know the sub array will be from. This is something that we already know. The sub array will be from the breakpoint plus 1 till n, right? This is going to be our sub array. Now in this sub array, we need to check which one is the minimum value, which is just greater than that value at the breakpoint. So simply again we will have a for loop. Again we'll start from the end, n minus 1 till the breakpoint, and as soon as we find out that if that value of I becomes either greater than or strictly greater than that value of the breakpoint, then I'll have a swap with I and break. Now the swap algorithm we have already have it, so we must have implemented it somewhere. Like we can implement it in a function, that same swap algorithm. Then once we have swapped it, what we can do next is just reverse the remaining. So you can now, using the similar function, we can like implement one more function with this swap reverse one, which we have already seen it, right? Reverse the string. So same algorithm we can use, and then we'll just pass it the array, pass the array, and then we will say we will pass it from like the breakpoint plus one till n, and it will reverse the remaining array, like that remaining array, and then we can just return this. So I hope this algorithm is like now a bit clear. Okay, I'll try to show you Java. Okay, so this one is in Java. So that's why like this is the pseudocode. You can just write it in any language, and this one is in Java. So I'll try to explain this code. Like it's very simple. So you can see what I've done here is, so you can say I've like given one variable k and one variable j. Then I've checked if it is like how I'm trying to find out the breakpoint. As soon as I'm trying to like get the breakpoint, what I do is one more check. If suppose there is no breakpoint, if there is no breakpoint, that means the complete array is actually in decreasing order, right? If there is no breakpoint, so that means we can directly reverse that array, and that will be the next permutation. Else, what we need to do is we need to again check and find out the next element which is just greater than the breakpoint, right? This k is actually the breakpoint value. And what we can do is, if we just found out, we will swap it. Either you can write it in a separate function, or you can just like swap it. So the temp variable like that, swapped it. Once I've swapped it, I just again, what I'll do is I'll reverse the remaining. So from the breakpoint, and as we already know, like the starting value will be the zero value. Like from start till the end, end value will like automatically will be the n minus one. So this is the swapping reversing function. If we just run this code, you see it is passing this test cases. So just submit this code. See, it is beating all the solutions out there, 100%. Okay, so I think this one is a good question. It was a medium question. So yeah, this one is clear. Can you please okay, yeah, sure. Mm, okay, I'll just quickly recap it very fast. Okay, what I did is in the pseudocode, I just created one breakpoint. Okay, just created one breakpoint, right? Then one for loop to find the breakpoint, right? In the code, what I did, in case I find a breakpoint, otherwise, if I don't find the breakpoint, what will be? In that case, like if since there I was starting with like comparing with plus one, here I can do is like minus one, then the k value will be zero, right? If the breakpoint, if I don't have any breakpoint, right? In that case, what I can say is if k is equals to zero, then just reverse it. So I can just have a if and else case here, right? Like you can just have an if case if k is equals to zero, then simply reverse it. Else, else part will be this one. In this part, what we need to do is loop it until you find the just next value which is greater than the breakpoint, right? As soon as you find it, you'll just swap that value. Once you swap that value, what you'll do, reverse the remaining part. To take that example which I have taken, 2 1, yeah, so 2 1 5 4 3 double 0. Start from here, stop when you find the breakpoint. This is the breakpoint, right? Store it somewhere in a variable with break. We already have that. This is the array in which then next we are interested in. Find the value which is just greater than this and is minimum here. So I just again and then I'll stop it here. Okay. Then when I found this value, I'll just swap it. Swap it, then it will become through 2 3 5 4 1 double 0. Right? Interested array is this one, just after the breakpoint. Now reverse this. 2 3. After reversing, double 0 1 2 5. This is the right answer. I hope now this is clear. So this is like a very interesting question, and actually this depends upon like this intuition, right? Reversing. If anytime like you see this question, so I think recently I have seen this question, and actually I was not able to like solve it, but it was a pretty interesting and like it was a difficult question. So uh, like very hard questions can also be formed out of this, and only thing you need to remember is like reverse when it's whenever you see the permutation. Okay, just remember this algorithm how to find out the next greater permutation. As soon as you like have that in your mind, right, you can like find out with the next greater permutation very easily. So there can be many questions formed on this. So the question what I got is it was similar. It was asking for the next permutation, but there was some conditions out of that. I don't remember exactly, but it was something like this. Okay, you have this array, right? Like the next permutation is this one. What they were wanting is, I think, uh, something like this. It was like, yeah, right. So instead of this, what this said is, okay, this gave some condition, right? Like if I is less than j, then actually like the number of I should be greater than number of j. It was very easy, right? What they actually meant by this should be in the decreasing order. That's it. So what actually like wanted to return is this one. That's it, and that this was the answer, right? But I just forgot this one, right? The reversing algorithm, and time was like very less. This was the last question, so unfortunately I missed this question. It was like once you remember this algorithm of reversing, this like reversing, swapping, and then reversing, then all the questions made out of these are like very easy. Like they will give you the next permutation, and they will like add some conditions like this, and you just need to figure out. Like they can say, uh, in the next permutation, the last value should be the greatest one, something like that, or the first value should be the greatest one, something like any condition they can have. Okay, so this is good. Um, should we move to the next section? So these are mainly based on the array operations and somewhat two pointers. The next section, like I have, is more focused on the two pointers only. So if we are good, should we take one or two questions, or um, should we wrap up? Or like if it is getting too heavy, we can wrap it up. You can give a thumbs up in case you just like, if you're okay, we can continue. Okay, then we can continue. Okay, so we'll take this. This is a two-pointer approach. So I'll just give a brief about these two pointers. Okay. Mm, in the previous algorithms, what we have seen is there is something like when, like, suppose we're reversing the array, right, or swapping the numbers, or like uh, just take an example of reversing the array. We were actually taking two pointers. Pointer is nothing but like it points to the index in the data, or it is just the storage of particular address, right? The address, like the if it is the first address or it is the last address. So it is a pattern in array, and some questions can be solved with this pattern of pointers. So actually there are two patterns. One is the point, this two pointers, and another pattern is sliding window. So sometimes people get confused in between these two, and so let me just clarify. And when we will like go on the sliding window, then like it will be more clear. But just quickly, I'll tell the differences between two, right? Like the two pointer and the sliding window. Okay, so two pointer approach is like whenever we do not know like what is going to be the length, right? So in the reverse one, if you have seen, we were having two pointers. One was starting from 0, the another pointer was starting from n minus 1. In another question, what we saw is the one pointer was starting from some breakpoint, right? And like while reversing, and then another pointer was at the n minus 1. This is something which is not fixed, right? The distance between them. Like it can start from anywhere. It can actually go in this direction, this can go in this direction, right? This is going forward direction, this pointer is going in the backward direction. But actually, it can also have like this P1 going in this direction, P2 going in this direction. But just imagine what happens is this is actually not two pointer. In case like both are going in the same direction, this is also going plus one, this is also going plus one in each iteration. This is not a two pointer approach. This is actually the sliding window. Why? Because the window is fixed here, right? Suppose if I have an array from 0 to n, right? And my pointer is starting from 0, this one is starting from 2, and or let's say 3. And every time I'm going just plus 1. So next will be 1, 4, 2, 5. So window is fixed, right? I'm creating a window like this 1, 2, 3, 4, 5. The first window is from this to this. The length of this window is fixed. Then I'm going from this to this, then this to this. I'm just sliding a window, right? Like I'm just creating one window like this, and then I'm trying to slide it. So the length of this is fixed. So this is actually not two pointer, this is the sliding window. So just for the clarification that sometimes people confuse it with the two pointer, all like this one is also the two pointer approach, but this one is actually not the two pointer approach, right? The only difference is what, that whenever you see that the window is actually fixed, like the window between P1 and P2 is always fixed. Suppose if this is going plus 1 and this is going plus 2, right, every time, then 0, 3, then this will be 1, then this will be plus 2, 5, then this will be plus 1, 2, this will be what, 7. Window is what, 3, window is what, 4, window is what, 5. Here the window is what, is it is not fixed. So this we can say. In case if it is like plus 1 and this the another pointer is going like plus 2, this is up to pointer approach. But if it is like both are going plus 1, then that it becomes the sliding window approach, the sliding window pattern. Okay, so just brief about two pointers and sliding window. Just quickly make this. Okay, The next question. Yeah. So we are given two integers, arrays, num1 and nums2, sorted in a non-decreasing order. It's just another way of saying of increasing order, right? One, two, three, increasing order. And two integers m and n representing the number of elements, right? Merge nums1 and num2 into a single array in non-descending order. The final array should be not be returned by the function, but instead of sorted inside the array nums1 to accommodate the nums. So we will go this through. Okay, like, well, first we will try to figure out till this portion. Okay, so actually it can be formed into two questions, right? Like uh, it can be like this can be one question, and if you take into consideration these conditions, then this can be like another question. So I'll take some example. Let me find out some example. Okay, suppose one, yeah, simple example, 1, 2, 3, 4, 5, 6. Okay, now I just want to merge this array. How can we do it? Anyone wants to attempt? How can we merge this array and form one more array? Since like we have to form one more array, we have size this n, we have size of, suppose this is size of n, 1, 2, 3, 4, 5, 6. We will be having m plus n, 6 array size. Since our arrays have a fixed size, we need to know the array beforehand. Okay, Shreya has said mid. Can you explain a bit more, like uh, what mid values are like, how we can utilize the mid values here? Right. In case like can take one more value, right? Might be okay. Let me do one thing. Let me make this 5 here. Okay. Then make this 2, 3, 7, 8. Right. It can be like this also. This is also increasing. This is also increasing. Like try to actually solve this question by just forming a logic, right? Just if you are able to form a logic directly in your head, I think that is enough. Like this question is very intuitive. If you just can think of like without thinking programmatically, just think of like how we can form a new array, like write this array. So if I say I have the 6 positions, 1, 2, 3, 4, 5, 6, right? What should be the first value? How can I find what should be the first value? Right. Sharon said one. Can you explain like how you have selected like one? Mhm. Right, absolutely right. So since we already know, right, that this is an increasing array, this is also an increasing array. So we just need to fill up this with the lowest possible array or the minimum array. Also, sorry, the minimum possible integer. How can we find it? We can find it by the like the what we can just compare. So this one will be the minimum of n, right? This one will be the minimum of m. Now what we need to do just to find out like the least value is compare these two, right? Minimum of m and n, which is minimum 1. That's it. Now the next value, since this one is already done, right? Simply what I'll say, I am having a pointer p of m, which is pointed to this. This is already done. I'll do plus plus of this value. So this pointer will come to here. I'll define a pointer p of n, right? Initially, both will be from the first value. So this is still in this position, right? So I'll say this pointer is still in this position, but this pointer is shifted to this. Now what I'll do, again the same thing, right? Compare both these uh, value, whatever is the minimum. Which one is the minimum? Both are equal. I can take any one of it. So I can just take for like I can take the left one. I can give precedence or like priority to the left one. I'll write the 2 here, increment this. Then again the same thing. Compare these two. Which one is the smaller one? 2. Okay. Fill this one 2. Increment this one. Then again what? Compare this with this. Both the pointers. Which one is the smaller one? 3. Very easy. Fill 3. 3 is filled. Increment this. Now again same. 7, 5. Smaller than 5. Increment this. 8 and 7. Smaller. Which is smaller? 7. Then increment this. Okay. This is like end of our array. So remaining value is what? 8. You just say 8. That's it, right? So I think it is very intuitive, right? Just need to know that okay, this is one pointer, this is one pointer, right? So how this is two pointers? Here actually you are having two different arrays. The pointers are in actually two different positions in two different arrays, right? This is also a two pointer question pattern. Like this is also a two pointer question pattern. It doesn't like always mean to have both the pointers in the same array. It can be in different arrays. You just need to have like we are storing two addresses. These are two addresses, and when this we are just comparing it and filling the new array. That's it. Now this one like okay, I just tried the pseudocode for this. Suppose we have nums1 array already given, and we have nums2 array already given, right? Then what we need to do, we can have a pointer p1 starting from 0, pointer p2 starting from 0. Then we can have a while loop. We'll just say any pointer like p1 should always be less than n. Let's say this is n, right? First one, the length n1. Let's say this is length n1, this is length n2. p1 should always be less than n1 and p2 should always be less than n2. Okay. Now what we need to do is compare the first values, right? So okay, we will form one more array, nums3, or let's call it the result array, right? And the size of this will be n1 plus n2, right? This is what we will create, initiate. Now once we have initiated this, we need to also know like we can have one more index array. I'll initiate with 0. So this will help me to keep track of where we are in the result array. So then we can have an if condition that if the nums1 p1 pointer, right? If this is less than or equal to outside nums2 p2, right? This is fine. if it is less than equal to a2, what I simply need to do is result of I need to fill the smaller one, which is what nums of p1. Then what I'll do, increment both of them. We'll just write plus plus. Okay, I'll just write separately. Like p1 plus plus, comma I plus plus. Okay, then else case. In else case, result of I will be actually p2. Then simple p2 plus plus I plus plus. Right now, what will be at the end? Either of this will end, right? Suppose in case I'm just supposing like n1 is much smaller, right? Like n1 value is like 5 and n2 is actually 10, right? And I'm assuming that suppose this one ends first, right? Like this was the case. So here we have actually ended here, right? Suppose there were many values after this 9, 11, 13. So we can observe that like if this one is ended, we still have remaining values here. Right? This one is ended, that means all the values that we are having here, right? Till here we have compared. All the values which will be after here will actually, like we can just say, we can directly write it will be greater than, because if suppose some value is less than 7, right? Suppose, then it should be like before this 8, right? It will always be inside the cell. Like we must have already taken care of that value. So we can add two more conditions. In case p1 is like still less than n, right? Then what we'll say is simply until p1 is less than n, inside the result plus plus, I'll do it separately. Keep on adding that value, so nums1 p1, then I'll do p1 plus plus I plus plus. Now similar condition, in case p2 is still less than n2, have a while loop with what p2 still less than n2, and result of I equals to nums of p2, p2 plus plus and I plus plus. So this will take care of the remaining portion. Okay, can give a thumbs up that this is okay. Okay, fine. Now what we'll do, we'll read the portion that we actually skipped. Okay, and it is actually pretty simple. And I'll explain it to you. But what I'll suggest is like try to do it by your own. So it is like a variation of it. So what it says is the final sorted array should not be returned by the function. So, but instead of stored inside the nums1, right? What they're saying is like instead of creating a new array, store all the values in the nums1. So that means like to accommodate this nums1, already they have given that nums1 have a value of like length of n plus 1, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and it should be ignored, right? So what they say is like we have taken this example, right? 1 2 5 8 2 3 7. So in the question you will actually be given 1 2 5 8, right? And the remaining one. So in this length, what they have given us n plus n. N is what? 2 3 7 3 0 0 0. and this array what they has given is 3 3 7. So instead of like creating a new array, you just need to have like the final array, which was what 1 2 2 3 7 5. This was 1 2 2 3 5 7 8. You should like the nums one should be like should become this, right? So it will be like so try it by yourself, okay? And check if this is updated. Yeah, yes, yes, they are updated. So yeah, this thing is not working yet. So you can attempt these questions. Sure. Yeah, and the question is said, right? It is given. Num initially it will be m plus n. Correct. I'll show you the question as well. Like the example of this one is the question. You can see here, right? Piece of text a little bit clear, right? They're given it like in this way: 1, 2, 3. These are 0. Then it's like 2, 3, 5. So we can like try to solve this, okay? And I think it will be like pretty clear then. Okay, okay. Then I think it's all good for today. So if anyone have any doubt, we can now take. This much is enough for today. Okay, I think if there are no doubt, and we can just wrap up. Thanks for joining, everyone. Thank you.